All right, so today we're going to start 3.6. I'm going to break this up into two parts. We're going to look at just the polynomial inequalities today, and then we'll look at rational inequalities later. So when we're looking at polynomial inequalities, we have some steps. The first thing we want to do is find the values of x that satisfy the equation. So we're going to kind of remove the inequality and then put it back. So if we look at this first example, solve each polynomial inequality, write each solution in interval notation. 2x squared plus x is greater than 15. I'm going to rewrite this so that it becomes an inequality with 0. So 2x squared plus x minus 15 is greater than 0. So it means we're looking for whenever this polynomial function is positive, so above the x-axis. And so what we're going to do is we want to figure out where are those x-intercepts? Where is it changing from the positive side of the graph to the negative side of the graph, and so forth. So first thing we're going to do is solve for x. So 2x squared plus x minus 15 equals 0. Since we have a quadratic here, we can either do quadratic formula, or we can factor. And I'm going to factor this. So 2 times negative 15 is a negative 30. And our factors of negative 30 that add to be 1 are 6 and negative 5. So we have 2x squared plus 6x minus 5x minus 15 equals 0. Factor by grouping. We can factor out a 2x. We're left with x plus 3. Then factor out a negative 5. And we're left with x plus 3. Our factored form, x plus 3 times 2x minus 5 equals 0. And then if we set those both equal to 0, we get x equals negative 3. And then 2x minus 5 equals 0. X equals 5 halves. Okay. So I'm also going to write in x equals 2.5. Just because we're going to put this on a number line. Okay, so if I draw like our x-axis, okay, we now have a point at negative 3 where our graph crosses, another point at 2.5. Okay. All right, so now we need to figure out what's happening. So this is an instance where you can either graph your function and determine where it is it above the x-axis or below? Or we can just find test values and plug them in. Okay. I'm okay with you doing either method, but we're going to do the test values. Okay, so to find a test value, we're going to pick x values in each of these intervals. Okay, so something to the left of negative 3, well, that would be, let's just use negative 4. So when x equals negative 4, and we're going to plug this in to our inequality. So 2 times negative 4 squared plus negative 4 minus 15 is greater than 0. Well, negative 4 squared is 16 times 2 is 32. And then negative 4 minus 15 is a negative 19. It's greater than 0. And let's see, if we combine those, we get 13 is greater than 0, which is true. So I'm going to come up here and I'm going to put a T for true. All right, now let's pick another value. So let's do 0. That's a nice easy one. So when x equals 0, we have 2 times 0 squared plus 0 minus 15 is greater than 0. So is negative 15 greater than 0? That's false. And then going to the right of 2.5, let's just plug in 3. So if x equals 3, we have 2 times 3 squared plus 3 minus 15 is greater than 0. 3 squared is 9, times 2 is 18. So we have 18, and then 3 minus 15 is negative 12. 18 minus 12 is 6, and 6 greater than 0? Yes, so that is true. So I'm going to come up here and put a T. All right, so now we can shade in the areas on our number line where this is true. And then we need to figure out, are we going to have parentheses or brackets? Okay. So when we're solving this, since it says greater than, it doesn't want us to be equal. That means we're going to have parentheses. And then we're going to write that out in interval notation. So our solution here would be negative infinity to negative 3, parenthesis, union. And instead of 2.5, I'm going to go back and I'm going to write that as 5 halves to positive infinity. Okay. If you were to sketch this graph, so we have negative 3 and we have 5 halves. We have this quadratic. We know it's spacing up. So I'm just going to kind of sketch this. This is not going to be very accurate. But it looks something like this. Okay. This is our positive side of our graph, and this is our negative. Okay. So these intervals we just found is this part of our graph. So that is another thing we could have done. We could have just graphed this function and determined, okay, here's our x-intercepts, and this is where it's going to be above. If it wanted to know the negative, so less than 0, it would have been from negative 3 to 5 halves. Okay, one thing I want to point out, yes, you can see this goes true, false, true on our number line. True, false, true on our number line. Those will not always alternate. That is dependent on whether or not you have a multiplicity. If you have a multiplicity, remember our graph bounces back, which means you're going to have a true, true. Okay, so be careful about that. Don't just assume that it's going to be alternating true, false. Okay. All right, so I want you to try number 2 and 3. At least get it factored. Okay. If you can at least get that factoring part done, and then we're just testing values. Okay. And we'll go over that in class tomorrow.